Hey kids, welcome back to class. Today we will be doing what is that 8.3.2, but before we do that, do the CYU quiz in Edge Elastic for 8.2.1 that is linked in your Google Classroom, and you can pause this video until you're done with that. All right, so today we're going to be looking at classifying angles. What kind of angle is it? The nice part is we kind of already had a lesson on this about a couple weeks back here, or a week back. And so this should be review. All right, so first of all, I want you to pause your video and read all the vocabulary, review the vocabulary, and also take a look at how they're measuring this angle right here. So this angle, if you're reading, you have to read the bottom numbers because you're lined up on 0 here, and 0, 10, 20, 30, 40, 50. This would be a 50-degree angle between the rays and the vertex. So this is what creates your angle. So please read that and pause. Okay, for this problem here, 866A through D, I want you to measure, use the following GeoGebra tool to measure each angle in the sketch at right. Write the measurement in the table below, then classify it as either acute, right, obtuse, or a straight angle. Spelling counts, so make sure you're using the exact spelling in here. You'll use acute. Don't say acute angle, just say acute. So, and so on. Then part D of this problem here, I want you to draw in this space a straight angle. So to use the GeoGebra tool, you'll click on the link, and it's going to bring up those exact angles, and it's going to bring up this. So you'll want to line up the flat edge of the protractor with the long ray in each picture. To move the protractor, you click on the blue dot and you move it over to the vertex. And you may want to slide this around, grab it, slide around, zoom in so you can really see it. And then you're going to pull the red dot to line up 0 along the long ray if you can. And then your job is to count the number of degrees. Starting at 0, count. It's important to count. Don't look at this and say, oh, that's 150 something degrees. That doesn't make sense because it's not a very big angle. So you got to count. Here's 0, which makes this 10, 20, 30, plus some more, maybe 35 degrees. I want you to do that with each of the angles in this problem, A, B, C, and so on. And you're going to plug those in right over here into this space. Go ahead and pause your video, and we will come back as soon as you're done. I think I made an error in my my description. I would line the protractor up with 0 on the short ray, and then the long ray will be long enough to point at the number of degrees it is. And also, when you're filling in the angle classification, please make sure that you use acute and then angle. Type in the word angle as part of it. Okay, here we are back at this. These are the angle measures I got. For part A, it was 35 degrees, and it's an acute angle, so that 35 degrees is right in here. B, I got 122 degrees for an obtuse angle. C was a 90-degree angle, so I'm going to put this little box right here. And D was a 180-degree straight angle, which I drew as so. All right, next problem. Page 6. On this problem, I want you to explain. The diagrams below show some students' use of protractors. Explain in the text box below what each student needs to do to find the correct angle measure. Click on the X by the stoplight to make the image bigger. So when you zoom in on this, I want to know what these people did incorrectly with their protractors as they were measuring. Some of them can still be done, but they're not that correct. So, part A, you're going to tell me, in order to find the correct angle, what did this person do wrong? Help them fix their problem, A, B, C, and D. Go ahead and pause your work, and, your video, and then answer the question. Okay, so here's what we found out. Figure A, if they move the protractor to the left and line up this point right here on the vertex, more like you see in picture D here, that'll fix the problem. Part B is over here. In order to correct the angle measure, you should line up one of the rays on 0 degrees so the other ray will point at the angle measure, similar to D. So they have their thing rotated. I need to get maybe this ray along this flat edge. I would rotate my protractor. Problem C. In order to correct this, they need to push the protractor up so that this point is down here, like in picture D. Picture D is lined up quite well. The problem with picture D is that's not a 60-degree angle. It doesn't even look like a 60. It's an obtuse. It's bigger than 90. So they counted with the wrong numbers. Since they lined up on this ray along the bottom edge, they need to use the bottom numbers: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 10, 20, 120 degrees is what they should have for that angle. Let's move on to page 8 here. So on this one, we're going back to our complementary and supplementary angles. You might remember a little trick I did to remember that the sum of the angles is 90 degrees if they're complementary, and it's 180 if they're supplementary. Part A, you need to go back and accurately measure these three angles, and using our GeoGebra tool, you're going to type those accurate answers here and then tell me which pairs of angles are complementary and which pairs are supplementary. Then I'd like you to come up with a strategy for remembering those definitions. If it maybe come up with something that's better than mine, or remind each other of what mine was. Please pause your video and answer that question the same way you did before. All right, so after measuring my angles, I got 128, 52, and 38. If you got 127, this would be 53, and this would be 37. So when you look at these angles, angle A and B, they add up to 180. So I would say angle A is supplementary to B. B and C add up to 90. So I would say angle B and C are complementary. But then none of the other ones are true, because A can't be complementary to C. It's going to go over 90. So, in fact, my strategy for remembering my definitions was I did that thing where I said, let's see if I can write this out here. Hold on one second. Okay, so what I said is my strategy for remembering the definitions of complementary and supplementary angles is that I can turn the letter S into 180 degrees easily, and the letter C into a 90. Hopefully you have a better way than I do to remember it. Maybe you went alphabetically. 90 comes before 180 because C comes before S in the alphabet. I don't know. All right, let's move on to the next page, 10. We talked about adjacent angles. Adjacent angles are angles that have they have a common side, they have a common ray, a common side, a common vertex, and no interior points in common. So the angles don't overlap. They have to be right next to each other, sharing a ray. So we'll come up with some examples of that here in just a moment. But what I'd like you to do on the next screen is to take a look at each of those angles and sort them on the card sort under the appropriate word. So you're going to come over here to page 11, find the word adjacent angles and not adjacent angles, and I would like you to sort these out on your own. Go ahead and pause your video and do the sort. Alright, so here's what I'm finding, that if you have the adjacent angles are A, E, and I. Those are the ones that were adjacent because they share a ray and a vertex and they don't overlap. Where if you look at like C, even though they share this ray, some of the angle degrees of 1 are inside of 2. D, they don't even connect. They don't share a vertex or a ray. These share a ray, but they don't share a vertex, and so on and so forth. So A, E, and I were the only ones that match. Now, that are adjacent. Let's go to 12. And 12 we're going to do kind of quickly here together. So if you click on this E tool, vertical angles like angle 1 and angle 2, the ones that are across from each other, but they share a vertex only, and they come from two lines that intersect. They share this vertex, but that's it. And they're opposite each other. Like 3 and 4 are also vertical angles. Well, if I click on this GeoGebra tool, you can actually investigate the angle measures. So see how this angle, which was angle 1 and 2, and this is 3 and 4. If I open and close this, what do you observe? What do you notice about the vertical angles, this one and that one, or the top orange ones? What are you noticing about the vertical angles? No matter what I do, as long as I'm looking at vertical angles, they are always equal. So we're going to go back over here, and we're going to say in part A, angles 3 and 4 are equal. The actual word we should use is congruent, but we'll save that for high school. And we can say this, the measures of vertical angle pairs are always equal! Exclamation point. So now we'll just go ahead and put periods there. Alright, now page 14. Now we get into some of the fun where we get to use the math that we're learning. So find the measure of the missing angles. So for part A, show your work and explain how you figured out the missing angles in the text box that follows. You can enlarge the diagram by clicking on this plus sign on yours. I don't have that ability on mine for some weird reason. Anyway, for part A, angle 1 is 75. I need you to figure out angle 2 and tell me how. Now, if you use the definitions that we have, these adjacent angles make a straight line. I bet you there's something having to do with 180 in there. Problem B, these are vertical angles, and we just made a statement. Vertical angles are always equal. Problem C, these are complementary. What do those add up to again? Maybe go look. So I want to know angle 2 if this is 27. And angle D, these are supplementary. If angle 1 is 30, what's angle 2? So you need to go look at the definitions for those words, fill in the answers, and tell me how you figured it out. Go ahead and pause the video and do that, please. Okay, so part A, measure of angle 2 is 105 because 105 plus 75 would make 180. In problem B, I got 55 because these are vertical angles. They have to be equal. If angle 1 is 55, angle 2 is 55. Problem C, angle 2 would be 63 degrees because they're complementary and add up to 180. 27 plus 60, they're complementary, they add up to 90. Angle 1 is 27, angle 2 would be 53 degrees to make 90, and 63 degrees. Wow, I'm messing that up. Problem D, these are supplementary, so they add up to 180. 30 plus 150 would be 180. And on to page 16. Oh, I want you to do a bunch of vocabulary work here. To notes to your future forgetful self, define adjacent angles and include some drawings that show what they are and what they are not. Define vertical angles. Include a diagram that shows vertical angles are always equal. Define complementary angles and provide an example. Define supplementary angles and provide an example. I think these might be some good examples over here. Title these adjacent, vertical, complementary, and supplementary angles. That way you have them in your notes. When you're done, go try this problem. These four angles, x, 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 and 36, add up to 90. These three angles add up to 140. I would like to know the value of x. So the problems below or to the right describe other situations where some angles have been put together. For each problem, write an equation to represent the situation, then answer the questions. So part A, three angles that all have the same measure and one 36-degree angle combined to make 90 as shown. What is the measure of each of the three unmarked angles? In other words, what is x? And then part B, I'd like to, again, what are the measures of each angle? So you need to tell me, once you know x, then what is half x and half x? Challenge yourself. Try and get it right. After you're done, read this page, oh, and identify any vertical angles that might be in this picture that I made for Miss Parker one year. This is a pretty good one. That's Britain. Look at that. Have a great day.